Very good morning, students. For this lecturing video session, I am going to start a new unit, which is nothing but fourth unit, sections of solids and developments of surfaces. There would be two chapters. The first chapter is sections of solids and the second chapter is development of surfaces. For this video, I am going to give an introduction about the first chapter, sections of solids. In the upcoming video, I will give a detailed explanation, that means the introduction about development of surfaces. Let me just focus on sections of solids. Why is section is necessary or required? In the orthographic views, the interior hollow portions and the invisible outer edges or faces are represented by dotted line or dash line, right? See, invisible things we used to mention dash line or dotted line, right? Dash line or dotted line in this manner. So this represents the hidden, right? Hidden object. So interior hollow portion we used to mention this dash line. When the interior of the object is complex, these dash line or dotted lines are numerous. Therefore, the drawing is difficult to interpret. So, in order to overcome such difficulty, it is imagine the object is being cut truly, or that means completely or partially by an imaginary plane called cutting plane or section plane. That is nothing but cutting plane or section plane. Section plane or cutting plane. Cutting plane. This is an imaginary plane. So this can be represented by SP, that is section plane, and this can be represented by CP, that is nothing but cutting plane. Right. So the portion of the object between the SP, that is section plane, and the observer is assumed to be removed in order to show the invisible edges and the interior details of the object very clearly. Got it? So, suppose assume a cone. For an example, I am just drawing a cone. So, this is how the cone is being shown. This is the axis up to center. The line should come. This is the center of the cone, and these are generators. These are generator, and this point is nothing but apex or vertex, and this is nothing but the base, and this is nothing but the axis. Right. The cutting plane can be represented by long line dot, long line dot, long line dot in this manner. But both the ends should be widened. That means this should be widened. So, see, for the center, how you used to mention long line dot, long line dot, long line dot. This is for the axis. This is how we used to represent. See, for the cutting plane, the same manner, only difference is both the ends should be widened. Look at here, this should be widened. This is how you have to represent the cutting plane or the section plane. Suppose I am cutting this object by using the cutting plane in this manner. In this manner, assume if it is been cut in this manner. So let me just draw it here in a detailed manner. So the object is being cut in that way. So that is parallel to the base. The cutting plane is parallel to the base, isn't it? So this is axis. So now while cutting the object, this portion, the top portion will be removed. This top portion will be removed. So, the removed portion would be in this manner. And this can be represented, right? this. So this is the removed portion, and this portion is called remained portion. See, the imaginary process of cutting or sectioning is called sectioning. Sectioning is nothing but cutting the solids, right? And the removed portion, there is the minimum amount where you have, that is the removed portion. The major portion is assumed as remained portion. This is how you have to show the sectioning. And the line which I drawn here, the process of drawing the section line is called hatching. Hatching is nothing but, suppose a square object is there, right? Assume a square object is there. The hatching is nothing but to show that section lines. This should be 45 degree. This should be 45 degree inclination. This should be 45 degree inclination. The section lines are hatching lines, right? These are hatching line, hatching lines. The process of drawing the section lines is nothing but hatching, right? So what do you mean by sectioning then? The imaginary process of cutting or sectioning the object is called sectioning, right? And the gap between these two lines should be 1 to 3 mm. The gap between the section lines or hatching line should be minimum 1 to 3 mm. Got it? Right. So, see, as far as the sections of solid is concerned, we have 5 types. There is a various types of the section planes. See, in the points we have learned some 4 various positions, and for the straight lines we learned 6 various positions. Similarly, for the planes also we learned 6 various positions, and for the solids, projections of solids also we learned 6 various positions, isn't it? And here, as far as sections of solid is concerned, the types of sections, this represent the section plane or cutting plane. The types of sections, the first one is SP. SP is nothing but section plane or cutting plane. SP or cutting plane. CP is cutting plane, SP is section plane. Is perpendicular to VP and parallel to HP. This is first condition, right? And 2, the cutting plane, the section plane or cutting plane is perpendicular to HP and parallel to VP. The third section plane is perpendicular to both VP and HP. And the fourth type is the section plane or cutting plane is perpendicular to VP and inclined to HP. And the last type, say, as far as sections of solid is concerned, we have only 5 types, right? So the section plane is perpendicular to HP and inclined to VP. See, section plane and cutting plane. What do you mean by plane, by the way? Plane is a 2-dimensional object. It has only length and breadth. Assume a scale. This is length and this is breadth and negligible thickness. That is called projections of planes. That is plane, isn't it? So section plane is also in that manner only. It's a 2-dimensional object. The purpose of section plane is in order to view the interior portions or the hollow portions of the solids, right? For an example, let me just take this square prism, right? It's a square in shape, the top face and the bottom face of square shape, isn't it? So therefore it is a square prism, right? So the first condition, look at here, the section plane or cutting plane is perpendicular to VP and parallel to HP. First, let me just keep the object in order to just make you understand. So the ground as horizontal plane and the board as vertical plane, just assume it. This is a two-dimensional object, isn't it? So now, if I keep the object as per the first condition, so if I keep the object in this manner, now look at here, the plane surface is parallel to HP and it is making 90 degree, that is perpendicular to VP. This is the position of this object, that is section plane. Now I am going to cut this object in this manner. So look at here, this is the object, right? Now if I keep the object in this manner, that means the section plane, it is perpendicular to VP and parallel to HP. If I cut in this manner, this is called sectioning. If I cut it, this top portion that is being removed and the balance portion which is sitting on the base is nothing but the removed portion. So by doing so, you can see the interior or the hollow portion of the object, right? Next, let's move to second one. The section plane is perpendicular to HB and parallel to VP. So first condition, I have kept the section plane in this manner so that the plane surface is parallel to HP and perpendicular to VP. Now it says perpendicular to HP and parallel to VP. If I keep the object in this manner, that is the section plane, if I keep the section plane in this manner, this plane surface is parallel to VP and it is making 90 degree with HP. Therefore, the section plane is parallel to VP and perpendicular to HP. This is the second position. Now, let me just take the object. So now look at here. If I cut in this position, that means the section plane is parallel to VP and perpendicular to HP. If I cut this manner, say if I cut in this manner throughout, then the front, this rectangular face will be removed. Got it? So this front portion will be removed and the remaining portion could be the rear side. Got it? So that satisfies the second condition. And the third condition, the section plane or cutting plane is perpendicular to both VP and HP. So first condition was in this manner, the section plane was parallel to HP and perpendicular to VP. In the second position, I have kept the section plane in this manner, therefore this plane surface is parallel to VP and perpendicular to HP. Now, if I want the both this, that means the section plane is perpendicular to both VP and HP, I should keep in this manner. So if I keep this section plane in this manner, this is making 90 degree and this portion is making 90 degree. Therefore, the section plane or cutting plane is perpendicular to both HP and VP. Look at here. This is the object, this is a solid, right? So we are under the chapter of sections of solid. So definitely the solid will be sectioned. So if I cut in this manner, now this section plane is perpendicular to VP and HP. This is how the sectioning would be done. Got it? Let me just move to the fourth condition of the sectioning is section plane or cutting plane is perpendicular to VP and inclined to HP. So this is how the object is, the section plane going to be, right? If I keep this angle becomes 0, it would be the section plane would be parallel to HP and perpendicular to VP. If I keep some inclination with respect to HP, that means the section plane is perpendicular to VP and inclined to HP. So the object would be cut in this manner. The object would be cut in this manner. So this top portion would be the removed portion and the balanced portion, that would be the remained portion. So the cut would be in this manner only. The section plane would be cut in this manner only. So now the section plane is making some inclination with HB and perpendicular to VP. This satisfies the condition number 4. Let me just see the condition number 5, which is section plane is perpendicular to HP and inclined to VP. If I keep the section plane in this manner, it is perpendicular to VP and inclined to HP. If I keep the section plane in this manner or cutting plane in this manner, it is making some inclination with VP. If I make this angle become 0, now look at here, section plane is parallel to VP and perpendicular to HP. If the section plane is in this position, now it is, the section plane is perpendicular to HP and inclined to VP. So the object would be cut in this position, right? So object would be cut in this position. If you just cut the object thoroughly, that means from the top face to the bottom face, this front face would be removed. That is the removed portion, and the balance would be the remained portion. Got it? So remember it. So section plane is nothing but the other name of cutting plane is section plane or cutting plane. Here the object would be section in order to show the interior hollow portion or invisible faces, right? So in the upcoming videos, I will just explain in a detailed manner how the section plane is used to cut the three-dimensional object, that is nothing but the solids. Hope you have understood the introduction about the sections of solids. Thank you.